Welcome viewers. Let us how to prove the fundamental trigonometric identities. Basically we have three fundamental identities. Those are sin square theta plus cos square theta is equal to 1, cosecant square theta minus cot square theta is equal to 1, and final one is secant square theta minus tan square theta is equal to 1. Let us how to prove for the fundamental identities one by one. Okay, so first one is I am taking A. So sin square theta plus cos square theta is equal to 1. Before we proceeding, we must know the trigonometric ratios of trigonometric functions. Sin can be written as opposite by hypotenuse. I am writing in short formly, it's a square, plus cos can be written as adjacent by hypotenuse, it's a square. So this is the LHS part I'm considering. So this is next is we are writing the whole square separately. So opposite square divided by hypotenuse square plus adjacent square by hypotenuse square. The next is you can take the LCM. So LCM of two fraction is hypotenuse square because the denominator part is the same. So I'm taking hypotenuse square is the LCM. Then the remaining part you can add the numerator of those two factors. Then opposite square plus adjacent square. By using Pythagoras theorem, you can directly written as opposite square. You can directly written as hypotenuse square by hypotenuse square. So you can cancel these two things. Remaining is 1. So the LHS part is sin square theta plus cos square theta is equal to 1. Hence the first fundamental proof. Got it? Then second one is I am taking that is B. Okay. So cosecant square theta minus cot square theta, that is equal to 1. Okay. So by taking LHS, cosecant square theta minus cot square theta. So here already we know sin cosecant is reciprocal of sine. So the ratio for sine is opposite by adjacent. So directly we can write as a reverse ratio. So this is hypotenuse by opposite, it's a square, minus cot is a reciprocal of tan. So ratio for tan is opposite by hypotenuse. So okay, here cot is again tan can be written as opposite by adjacent. So cot is a reciprocal of tan. You can directly write adjacent by opposite, it's a square. Okay, then next is I'm writing squares separately. Hypotenuse square, opposite square, minus adjacent square and opposite square. Now you can take LCM. Here observe the two fractions. Denominator is opposite square. So directly you can take the numerator of fractions. Here we have negative. So adjacent square. Okay. So by using Pythagoras theorem, we can replace this hypotenuse square minus adjacent square can be written as opposite square. How? So this is the question now. So by using Pythagoras theorem, hypotenuse square can be written as adjacent square plus opposite square. You can write this is hypotenuse square can be written as opposite square plus adjacent squares also. By rearranging this equation means I am taking this is adjacent square to the LHS side. So it becomes hypotenuse square minus adjacent square is equal to opposite square. So just I am replacing that hypotenuse square minus adjacent square as opposite square by opposite square. Now numerator and denominator are same. So the fraction value is equal to 1. So second fundamental identity is cosecant square theta minus cot square theta is equal to 1. So this is proof for second fundamental identity. Let's come to the third one, that is a C. C is a secant square theta minus a tan square theta, that is equal to 1. Okay, so same as previous proof, we can directly substitute the fractions. Secant square is the reciprocal of cos. Cos can be written as adjacent by hypotenuse. So I am writing this is a hypotenuse square by adjacent square. Directly I am writing here. Okay, minus tan can be written as opposite by adjacent square. Okay, so this is LHS part. So this is equal to, I am taking LCM here. So adjacent square is the LCM. Okay, remaining is opposite square. Sorry. Same by using Pythagoras theorem, you can use the hypotenuse square minus opposite square can be written as adjacent square. Again, this is adjacent square. Now it is equal to numerator and denominator of fractions are equal. So the value of the fraction is equal to 1. So this is the proof for third fundamental trigonometric identity. That is secant square theta minus tan square theta, that is equal to 1. Hence the fundamental trigonometric identities. Trigonometric identities. Thank you for watching.